For this video, we're going to talk about how to solve linear equations. So these are going to kind of jump up in difficulty pretty quickly. So we'll do some easy ones, and then as we move on, try to do the ones on the right to kind of just pace yourself with these. Alright, so the main goal with solving a linear equation is you want to get x all by itself. You want like x equals 3. So you need the x on one side and everything else on the other. You're basically just going to undo everything that's around the x. So for the first problem, I mean, it's almost silly. You basically, if you can't tell that x is 14 just by looking at this, you got some problems. So if you didn't, go back and think about this. Does 14 work? 14 minus 4, does that give you 10? So think about how could you feel that, just like look at this and see that it should be 14. Now if it's more complicated than this, you basically want to undo this subtraction of 4. So that's the opposite of subtracting 4. You add 4. And whatever you do to one side, you have to do the other. So x equals 14. And that's basically it. So you have minus 4, you add the 4 over, these 4s drop out, and you get x equals 14. To check it, plug in 14. So 14 minus 4, so plug in 14 for x. It's always good to put parentheses around whatever you plug in. Does that give you 10? 14 minus 4 does give you 10. Alright. So let's try 3 here. Now, what in the world do we do with all these negatives? So the first thing you got to realize is if you get two negatives stacked next to each other, what's a negative negative 4? Well, a negative negative 4, that's not a negative 4, it's the opposite of a negative 4, which is a positive 4. So we're going to write this as negative 3. Two negatives together makes a plus m, and that equals 10. So how do I get rid of this negative 3? I'm going to add 3 over. Now one of the things people have trouble with is they see this between these two as being addition and they want to cancel this addition with subtraction. Don't cancel this addition sign, cancel out this negative 3 here. So what we're left with? M equals 13. Now check is kind of annoying for this one, so this is what it would look like. Negative 3 minus a negative and then a positive 13. Alright, well the two negatives still make a positive, so it's negative 3 plus 13. Does that give me 10? And yes it does. Alright, well I'm not going to skip 4 in this case, just because of the fractions. So we're going to add over this 2 over 15. Because how do you get rid of a minus? You add it. So plus 2 over 15. So how in the world am I going to add 1 fifth plus 2 fifteenths? And I'm hoping you're not going to say it's 3 over 20. Can't just add them down. They need to have like terms, or like common denominator, sorry. So, what's the common denominator between 5 and 15? Well, it's 15. So how do you make the 5 become a 15? You multiply it by 3. You can't just multiply the bottom by 3 without multiplying the top by 3. So this side is 1 times 3 is 3. 5 times 3 is 15. So 3 fifteenths plus 2 fifteenths is 5 over 15. Remember, these are going to cancel. Now, this answer will not get you full credit because 5 over 15 is 1 over 3. Take a 5 out of 5 one time, take a 5 out of 15 3 times. Alright, so how do we check this? We plug in 1/3 for x minus 2 over 15. Now, to tell you the truth, the easier version of this would be to go with this 5 over 15. 1/3 is 5 over 15. Multiply top and bottom by 5. 5 times minus 5, 5 times 3 is 15. 5 over 15 minus 2 over 15. Does that equal 1 over 5? That doesn't look like it. 5 minus 2 is 3 over 15, which is actually 1 over 5, if you take a 3 out of top and bottom. Now, on tests and all that, if you're solving equations, if you run out of time, I understand not checking things. But if you have plenty of time, if you turn in the test, like 20 minutes to spare, and you haven't checked your stuff, I don't feel very sorry for you because you can always check your answers. You can always check them easily to see whether you're right or wrong. Alright, let's do some other quick ones here. So, 3x equals 30. What's between the 3 and the x? It's always multiplication if you don't see anything. So I'm going to do multiplication with division. So x equals 30 divided by 3, 10. Now we can even check these in our head. 3 times 10, does that equal 30? Yes. How do you get rid of divided by negative 3? This is the division symbol. If you don't know the fraction, x, like fraction negative 3, that means x divided by negative 3. So undo it, multiply both sides by negative 3. So on the left, the negative 3's cancel out. Negative 4 times negative 3 would be a positive 12. So negative times negative is a positive. Is a 12 divided by negative 3, negative 4? Well, 12 divided by 3 is 4. There's only one negative, so is it negative 4? Yes. Alright, more fraction stuff. Let's do most of the fraction stuff together. Alright, first things first. You get two operations going on here. Do we get rid of this divided by, multiply by 1/2, or do we get rid of this minus 1/8? So you got to think about what's the farthest away from x and get rid of that first. So this 1/2 is right next to it. I could multiply everything by 2. Or multiply everything by, yes, 1/2, or 2 divided by 1. But the easiest thing to do is to move over this 1/8 first. So add 1/8 to both sides. It's also easy because they're like terms. So you get 1/2 x equals 7/8 plus 1/8 is 8/8, or just 1. Okay, how do we get rid of this 1/2? So there's a couple ways of thinking about it. You could write this as 1/2 x is 1 times x, which is x, and then with a 2 on the bottom. This is exactly the same problem. So take a minute to see if you can wrap your mind around this. This is like 1x over 2. X itself is like x over 1. So if I solve this problem, like 6, I multiply both sides by 2. So if you see that, then that's what you want to do. If you don't see that, then one of the rules for fractions in front of variables is you multiply by the reciprocal. So reciprocals will flip. So the 2's cancel out, the 1's cancel out, and you're left with x equals 1 times 2 over 1, which is just 2. Alright. Now the check of this one's a little bit tougher. And it might actually be easier to use the calculator to check it. So let's show you how to do that. So in the calculator, you're going to type in 1/2. So 1 divided by 2. So that's our 1/2. 1 divided by 2. Parentheses, and then x is 2, we said. And then we want to subtract off 1 divided by 8. So that's our left side. We should get 7/8. Hit enter, and we get that nasty decimal. So to turn a decimal into a fraction, so I did it up here earlier in my calculator, you hit math, and then you go to fractions. So the math button's right here, fractions number 1, you hit enter, and you hit enter, and you get that 7/8. So that's using a fancy calculator to check any of these problems. Alright, now let's jump down to number 9. So we got multiple x's on these problems. So first thing you do is combine like terms. If you haven't watched that video yet, or if you don't know, if you need to watch the video, you might want to watch that before this, because we'll use the distributive property, we'll use combining like terms as well. Alright, so on the same side of the equation, so you're just going to put them together. 3.5 minus 1.5 would be 2. So 2x plus 5 equals 8. Now the farthest thing away from the x would be the 5, so we're moving over 5. So 2x equals 3, x equals 3 halves. 3 divided by 2 is 1.5. Now I'll take either of these answers, but since there are decimals in the problem, you might want to go with decimals. So if you want to check this, I would suggest, especially when it's decimal, to use the calculator. So do it back at the last problem to check it out and see if you agree. Alright, let's try it. We get the distributive property here before we can do anything else. So we get negative 4x plus 6 equals 22. Just root your 2. And then we have to get the x by itself. So move over to 6. 4x equals 22 minus 6 would be 16. And then divide by the negative 4 to get rid of the negative 4 in front of the x. And x equals negative 4. Let's check this one by hand. We have 2, we have negative 2 times negative 4 plus 3. Again, the order of operations video is kind of important here, so if you haven't watched that, or if you're supposed to watch it, you should watch it before this. So in here we got 2, this would be 8 plus 3, so it's 2 times 11, which is 22, and we've checked it. Alright, let's try 11, that looks tougher than 12. So, you get a big division bar. How do we get rid of that? So, how do you divide by 4 in general? Is you're going to multiply both sides by 4. And you got to do that really before you want to move over the 2, because the 2 is being divided by 4 already. So these 4's drop out. And you got negative 7x minus 2 equals 40. And that first step of getting rid of this fraction bar is usually all it takes. Because once people are here, most students are able to finish this out. Add over the 2 to get rid of that negative 2. You get negative 7x equals 42. And then between the x and the 7 is multiplication, so we divide by negative 7. And you get x to be 6. So if we want to check it, negative 7 times 6 would be negative 42 minus 2 over 4. Ooh, I made a mistake. You can see it here because now we're going to get negative 44 divided by 4, which is negative 11. So what's my mistake? Negative 42 minus 2 would be negative 44, I agree. So we can almost see that this is 40, we would get our 10. What did I do wrong? Well, we gotta go back here. Our answer seems to be wrong. 42 divided by negative 7 should be a negative 6. And now a negative 7 times a negative 6 would be a positive 42. Alright, so 42 minus 2 would be 40. Divided by 4 is 10. Now that was a legitimate mistake that I made. If I hadn't checked it, I would have gotten it wrong. So remember to check it, it's important. Alright, let's jump down to number 14 here and see what happens when we get x's on both sides. Alright, so goal is to get x on one side and numbers on the other. Now it doesn't matter which side. Most of the time we get x on the left. My rule for an equation is you want to move the smaller one. And the reason you want to do that is because the next becomes positive. It stays positive. So how do we get this 2x to the other side? Well, it's a positive 2x, so to get rid of a positive 2x, we're going to subtract 2x. So what's left on the left side? Negative 3, and you get 3x plus 7. A lot of times people lose this negative, or they add 2x over because there's a minus sign. So this is a positive 2x and a negative 3. That's what you want to think of it as. So you move over this positive 2x by subtracting 2x. You leave the negative 3 alone. Alright, we get a plus 7, so get rid of that with a minus 7. So negative 3 minus 7 would be negative 10 equals 3x. Divide that by 3. Now, there's no fractions or decimals in the problem, so to see, which one we should do, it really doesn't matter. So negative 10/3 would be the answer that I would go with. Now, check this. This is a little bit trickier. Let's see here. I get negative 10/3. So I would do in my calculator is you kind of have to do both sides separately. 2 parentheses negative 10/3 and then minus 3. And then we get that. Okay, well whatever. We got 5 negative 2/3 for the x plus 7. And hopefully we get the same. Oh, I said negative 2/3. Well, I didn't put in the same number. So, alright, second answer brings back the last line. So I have to use negative 10/3, not 2/3. That was silly. So negative 1. Insert 0, 10/3 plus 7. If all goes well, I get that same nasty number. So you plug in your negative 10/3 on the left, you plug in your negative 10/3 on the right, and I get the same thing. As long as the left side checks with the right, we're good.